Hello, math friends. Welcome to A Squared Math and Stuff. In this example, we are going to continue working with matrix multiplication. We're going to start with example 2 because in my previous video, I showed you two different methods, well, essentially the same method, but different ways of setting up how to solve for matrix multiplication. So let's go ahead and continue on with the examples. Remember, the first thing we always have to do is look at the dimensions because that tells us first if we're able to multiply and then what the final dimensions will be for our product. So we have a 2 row by 3 column here. So 2 by 3, and we are multiplying that by a 2 row, 3 column. So the dimensions of both of these are exactly the same. Unfortunately, we are not able to multiply them because these two values are not the same. Remember, those inner numbers have to be the same. And since 3 does not equal 2, we cannot multiply this. We could definitely add or subtract these, but you cannot multiply. So this one is not possible. Let's go on to the third example then. In this, we have a 3 row, 1 column, so 3 by 1, and we are multiplying it by a 1 by 2, so 1 row, 2 columns. These corresponding numbers are inners. Our inner numbers are exactly the same, so we can multiply this. And we will actually end up with a matrix that's larger than what we're starting with. We're going to end up with a 3 by 2 for our final dimensions. So let's go ahead and work through this. I'm actually going to set this up with the second method that I showed in my first video. So I'm going to take my matrix A, this first matrix. I'm going to place it in the upper left, we'll say. So we have -5, 6, and 0. And then I'm going to take matrix B and I'm going to set it in the lower right-hand corner. I'm going to space everything out too to give myself room to write out my multiplication. All right. And from here, we created this whole system of lines kind of forming a table here. So we could see our resulting matrix form, and then we knew what lined up with what. All right. We are then looking at going across. So remember, we go across at the same time we go down. But with these, there's only one number. So that's why sometimes it gets confusing. And that's why I'm using the grid system on this one. Because if I go across and down, I only have the one number to work with, or one set of numbers. So in this box here, we only have a -5 times 3. Then in this box here, I will have my 6 times my 3, and then 0 times 3. Moving over to column 2 of matrix B, the intersection point is a -1 and -5. So I'll put -5 first, times the -1. We have 6 times -1. And then finally, 0 times -1. And then I will perform those operations. If I had more than one number in here, I would be adding that together, but we don't. So let's go ahead and just write that out. We can see here that we have 3 rows and 2 columns, just like the answer says we should. So let's take a look. -5 times 3 gives us -15. 6 times 3 is 18. 0 times 3 gives us 0. Here we will have a -5 times -1 gives us +5. We'll have -6 and then 0. So that is the final answer for multiplying these two, what look like simple matrices, but actually result in a larger matrix when you multiply them together. Let's look at the last example I have for you. In this last one, I designate a matrix A and a matrix B. So we're looking to find A times B. So let's set up A times B, and we have to look at the dimensions of A times B. Matrix A is a 3 row, 2 column. so 3 by 2, and matrix B is a 2 by 2. Our inner numbers are the same, so we can multiply, and our resulting matrix will be a 3 by 2. Before I continue, I want to take a look at B times A. If we were told to multiply B times A, we would have a 2 by 2 matrix multiplied by a 3 by 2 matrix, and these inner numbers are not the same. So had we been told to multiply B times A, it would not be possible, but we are able to multiply A times B. So just be aware that A times B in the matrix world does not equal B times A like it does in the multiplication world. So be very careful with that. All right, let's get back to this. Let's set this up. I'm going to set it up in the more traditional method that most of you are used to working with. So I'll set these up next to each other and we will go across and down at the same time. So we have -1, 4, 2, 0, 1, 2 multiplied by 1, -2, 0, and 7. Alrighty. With the more traditional method, we go across a row and down a column. So let's go ahead and do that. We are going to go across row 1 and then down column 1 at the same time. That gives us -1 times 1 plus across to the 4 and down to the 0, 4 times 0. So that's our row 1, column 1 position. I'm now going to go across row 1 and then down column 2. Here, let me go ahead and try and color coordinate this a little bit more for you. So I'll do this one in the green. So across row 1, down column 2. So we will have -1 times -2 plus across row 1 is 4, down column 2 is 7, so plus 4 times 7. So that completes, we're all the way at the end of row 1 at the bottom of column 2. So that completes our row 1 here. Let's move to row 2. We're going to go across row 2 and start off going down column 1. So row 2, column 1 gives us 2 times 1 plus 0 times 0. And then we'll go down column 2. So now row 2, column 2, we'll have 2 times -2 plus 0 times 7. So 2 times -2 plus 0 times 7. And then lastly, we're going to go across row 3, down column 1, and then down column 2. So across row 3, we have 1 times 1 plus 2 times 0. And then across row 3, down column 2, we'll have 1 times -2 plus 2 times 7. So 1 times -2 plus 2 times 7. We'll close off this matrix. And let's perform these operations. We will have -1 plus 0, and then 2 plus 28, 2 plus 0, -4 plus 0, and then 1 plus 0, -2 plus 14. And then finally, we can get our final answer here by adding these terms. We'll end up with -1, 2, 1, and then 30, -4, and 12. So that's our final answer. All right, that completes matrix multiplication. If you like what you saw, please hit the subscribe button down below, and I will chat with you later.